This video, we are going to start our AP Physics 1 course. We're going to go over the basics and we're going to cover some definitions. So because this is the first video, I encourage all of you to pause the video at opportune times, copy whatever you have down on your screens. Also, if there's any questions that you might have that I don't address in this video, please ask the next day in class so that I can clear up any kinds of confusion. In some videos, there will be a little bit of calculations, including this video, so make sure you have a calculator nearby. And without further ado, let's begin. So let's start off with a couple of definitions. There are three definitions that I want you to have. The first one is vector. So a vector is anything with a magnitude and direction. All right, simple enough. We'll be using this term vector a lot throughout this year, and so just keep an eye out for that. So now you might be wondering, Mr. Lee, well, what about magnitude? What is the definition of magnitude? Well, magnitude is just a very fancy way of saying the quantity or the amount of something. So for example, if you had 5 glasses of milk, the number 5 would be the magnitude. And last, that leaves us with scalar. All right, so with scalar, I'm going to highlight this in different color because these are the two big differences that we're going to be focusing on throughout the entire course. The difference between a vector and the difference between a scalar. So just to highlight the difference, a vector is anything that has direction. Okay, I didn't put the definition of direction here. Direction is like up, down, left, right, forward, backwards, north, south, east, west, and maybe even like 30 degrees, 45 degrees, 67 degrees, right? These are all modes of direction. Okay, so because we'll be dealing with vector and scalar throughout the year, make sure you commit this one to memory. All right, now the other thing I want to point out about vector is how it's represented in physics. So for physics, we have a lot of formulas and variables. So for example, there is this formula, capital F is equal to M times A. Now on the formula sheet, you'll see this written as a capital F with a little arrow on top of it, and this A with this little arrow on top of it. So when we are writing for physics, okay, if you want to be very specific about your notation, that little arrow represents vectors. Now, I'm going to be honest with you here. The vector notation for the formulas I do not use when I'm doing my work. But it is important to know that if you see it on a problem or on a formula sheet, the arrowhead represents the vector. Now you'll notice here this M does not have an arrowhead, and that's because the M is not a vector. All right, so just so you know, arrowhead means vector, no arrowhead, not a vector. Let's begin. Now, what I'm going to do is I'm going to have a couple of examples here. Now, because it's the first time we're taking your notes, just as a reminder, anytime I do a problem as an example, I would highly encourage you to copy it down and jot it down. So this is like my way of guiding you through practice, right? So the more practice that we get, the better. And so what we're going to do is we're going to go through each of these examples and we're going to discuss, which ones these are vectors and which ones are scalars. Well, let's begin. So if you're driving at 5 meters per second, okay, this is a scalar. Now, let's break this apart. So the term 5 here, this is the magnitude, okay, and the meters per second that you see right here, these are what we call the units. All right, and so in physics, every variable has a unit associated with it, and that tells us exactly what we are looking for. So units per second is a unit for motion or for speed or velocity, but that's for future videos. So it's a scalar because it has just magnitude. Compared to the example below, okay, this one is a vector. So we know it's a vector because it has the same thing above, but now it has east, and east is the direction. So one more time, if it has both magnitude and direction, okay, we have a vector. All right, what about the one below? The volume of a cube is 5 centimeters cubed. All right, so here's the easy tell. Are there any directions? Nope, no direction, therefore this one is a scalar. The temperature of the room is 78 degrees Celsius. no direction, scalar. Pulling with 50 pounds of force. Okay, so you might be thinking, well, if you're pulling, I can like imagine them pulling in a direction, right? But because direction isn't specified here, this term, as we wrote it, can be described as a scalar because it has just a magnitude. However, we have to be careful, and this will be updated in future videos. When we look at force, we always associate a direction with it, right? And the reason behind it is because we can imagine if we're pulling something, we're going in a direction. So this one was a little trickier example, but technically force is a vector. Okay, and this is just my way of showing you that the language that we use, we have to be a little bit more specific. Okay, so if we're talking about a vector, okay, we must include the magnitude along with the direction so as to not confuse the audience. All right. And the last two. The reason why I wanted to put these two, even though it's a pretty straightforward example, is that these two ideas is going to be the topic of our upcoming videos. So let's say you walked 50 meters. This is just a scalar, okay? And let's say we walked 50 meters northward. This one is a vector, okay? Nothing fancy or tricky there, but as straightforward as can be. So let's just talk about the two previous examples, okay? Pulling with a force of 50 pounds of force and walking. All right, so you'll notice that I crossed out what I wrote here as a scalar. And that's because in physics, variables are associated with either a vector or either a scalar, right? It can't be both. So what that tells us down here is if you walked 50 meters, and we call that a scalar, okay, there's a very specific term for this. This is what we call distance. And if you walk 50 meters northward, this is what we call displacement. And in that video, we'll go over exactly how you can determine the two. All right. Now, we're going to look into how we can add vectors. So I'm going to show you two different methods, the tip-to-tail method and the math method. These are the tools that we're going to be using throughout the entire course. And so even though we don't get practice right off the bat, we will be getting a lot of practice as the year goes on. So if you want to take the time right now to pause the video and just copy down this example, all right, let me zoom accordingly. So we have Poe the Raven, and there we go. All right, Poe the Raven is flying with a velocity of 10 meters per second. And there's a gentle breeze behind them that is blowing at 5 meters per second. So that it's pushing Poe forward. How fast is Poe flying? All right, so here are a couple of very helpful tools for physics. Okay, now because this problem didn't give you an image, it really does help if you draw a image. All right, so I'm going to draw a image. I'm going to draw Poe right here. That's Poe. I'm going to just represent Poe as a dot. And by the way, this is what we call the tip-to-tail method. Okay, I'm going to draw the vector. So for vectors, a arrow is the symbol that we use to represent vectors. So this is Poe's velocity, and this is, I'm going to label it, this is 10 meters per second. Now the problem didn't say if it was going up, down, left, right, and so I'm just assuming that it's going to the right. And this is a good time to mention that assumption. If your vector is positive, okay, it's a safe assumption that the direction is either up or to the right. Okay. Now it is entirely up to you and the problem to say what is in fact the positive direction. However, it is a very safe assumption, and for class, it is safe to assume that positive will always be upward to the right. Therefore, negative is down or to the left. Okay, and so because the problem said Poe is flying with a velocity of 10 meters per second, and that's a positive value, I'm going to just make Poe flying to the right. All right, and there's going to be a gentle breeze behind him, right? The gentle breeze behind Poe is 5 meters per second. So this is my breeze. Notice my arrows are not the same size, and it's because the size and the length of the arrows tell you your magnitude. And so because 5 meters per second is exactly half of that 10, I drew it just about halfway there. All right, so this is the setup of a problem. Now I'm going to perform the tip-to-tail method. So in order to perform the tip-to-tail method, what you have to do is you have to align your vectors so that the arrows start where one ends. So for example, my first vector I'm going to draw is this 10 meters per second one, by the way. So this is the tip to tail. Okay, so tip to tail, I'm flying 10 meters, or excuse me, post flying 10 meters per second to the right, and where that arrowhead ends, I'm going to add the 5 meters per second arrowhead, so that upon further observation, okay, we can now say it's as if Poe is flying 15 meters per second. All right, so that's the tip-to-tail method. We added the two vectors where one vector ends, the other one begins. All right, and at the very, very end, you just go from the very beginning and you create an arrow until the last arrow ends. So because my last arrow ended right here, okay, that is why I drew the arrow to that length. Okay, yeah, so the math method, as easy as it sounds, we just add 10 to 5, okay, and we get a total answer of 15. Now, as we are writing down our notes, okay, you might be thinking, man, this is it? It's really simple. Well, yeah, it just takes a little bit more practice, and there are a little bit more, I guess, more confusing problems, but we will tackle those when we get to it. So here's a big rule for the math method, okay? You can only add vectors along the same axis. So what I mean by that is both of these 10 meters per second and the 5 meters per second, these were x-axis vectors. Therefore, I was allowed to add the two together. All right? Let's say we had this 10 here and we had this 5 here. So if we take a look here, this here is the x-axis and that 5 is a y-axis, so we cannot just add 10 plus 5. Them's the rules, and we'll go over exactly why. There is a real life example of why we can't do this. Okay? All right, let's try one more. How fast would Poe be flying if the wind change direction is now going against Poe's direction? So let's do the same thing. We'll do the tip to tail method. We have 10 meters per second here, and we have 5 meters per second here. Now, just so you know, I'm not doing the tip to tail method right now. I'm just setting up the problem. Okay, so if I were to do the tip to tail method, I'm going to draw the 10 meters per second first. Okay, and where that arrow ends, my next arrow will begin. Okay, we have the 5 meters per second. All right, and finally, what you're going to do is you're going to draw a final vector from where you began. So like right around here. Yeah, so right around here, all the way to where you ended. So I ended here. So you can see that the length of my arrow looks like so. All right, in the math method, we do 10 meters per second. And remember, your direction matters. Because this arrow was going to the left, we're going to say minus 5 meters per second. Therefore, our answer is a total of Poe feels like Poe is flying at 5 meters per second. All right, that's that for this video. I'll see you next time. Bye-bye.